Okay, now we will see the difference when the used electrolyte is molten or dissolved in a suitable solvent. So, for a molten electrolyte, an ionic compound with a general formula Mx, so M plus here is the cation and X negative here is the anion, is formed by strong electrostatic bonds that exist between a cation and an anion. These oppositely charged ions are locked into a rigid structure where they are not free to move. In this case, electrolysis cannot take place, diba? As I discussed in the previous video, kadong solids. So one way to make this ionic compound conduct electricity is to heat it up to its melting point. So that's molten. And at the melting temperature, the cation and the anion are given enough energy which allows them to move freely. The melted ionic compound is now called the electrolyte. And when the molten electrolyte Mx undergoes electrolysis, it is simply split into its elements M and X. Kaya diba sa definition ganiha, sa electrolysis, mas-split ang substance, ang ionic compound. So, the two elements are M and X in their free form already, not in a compound anymore. So, for a molten electrolyte, so the cations in the electrolytic cell, the cations are attracted to the negative electrode, the cathode, where they gain electrons to form the metal atom. So, diba, positive siya, tapos mo gain siyag electrons para mo form og metal. Cations will form metals mostly. And then the anions are attracted to the positive electrode where they are going to lose electrons to form the non-metal nga molecule. So, kani ang ma-form M og X. Okay? So, the cathode is the negative electrode. It is where reduction takes place. So, si cation mo adto sa cathode para mo gain og electron so that a metal is formed. Sa anode, it is a positive electrode. It is where oxidation takes place. So, the anion will lose the electrons there to form a non-metal substance. So, in example, we have here a molten sodium chloride. The industrial production of sodium metal is done through the electrolysis of molten sodium chloride. So, diba? Asin siya nga gimelt and makaproduce siya og sodium metal. So, imagine that. So, it is carried out in specially designed cells called down cells or a down cell. So, here, calcium chloride is added to lower the melting point from the normal melting point of sodium chloride, which is 800 degrees Celsius to 600 degrees Celsius. So, instead of pure nga sodium chloride ang gigamit, gidugangan siya og calcium chloride para mo lower ang melting point niya. The anode and cathode chambers are separated by a steel screen to prevent contact between molten sodium metal and chlorine gas to reform sodium chloride. So, kung nakay NaCl, ang products ani sa electrolysis sa molten niya would be ang sodium nga metal, liquid which will eventually solidify, and chlorine gas. And sodium metal is a very reactive metal and chlorine gas is poisonous. So, para mo prevent ang contact between them, para mo reform o sodium chloride, so giseparate ang anode ug ang cathode nga chambers. Also, the reaction is extremely exothermic and explosive, and an explosive reaction might occur between the two elements if mo come in contact silang duha. So, the chambers must be separated. So, the sodium ions, which are the cations, they will migrate to the cathode, where electrons enter the melt and are reduced to sodium metal. The chloride ions will migrate the other way, moadto siya sa anode. They give up electrons to the anode and are oxidized to form chlorine gas. So, the overall reaction therefore would be, so gikan sa sodium chloride nga asin, mo form siya og sodium nga metal in liquid form, and then chlorine gas, gaseous nga substance, which is a poisonous gas. So this is how the down cell looks like. So this is the anode, and the cathode is here, kani siya. So naani siya giali diri barrier to prevent contact between them. So the chloride ions will move to the anode to form chlorine gas. So muning bubbles mo release din ha. And then the sodium ions will go to the cathode to form metallic sodium liquid, which is the outlet is here. So kani siya, this is the molten nga sodium chloride kani. And then the ions will go to their respective nga electrodes kung asa sila mo undergo oxidation or reduction. So you can use this video, you can watch the video here to see the actual process of producing sodium metal from molten sodium chloride, and also the chlorine gas, how it's produced in the factory. So you can watch the video through this link. On the other hand, so kado siya molten, this time it's an aqueous solution. So this time it's dissolved in water. So unsay difference kung molten lang or gidissolve siya in an aqueous solution? The electrolysis of an aqueous electrolyte, Mx, so take note we have the subscript here Aq already because it is dissolved in water. It's more complicated because of the presence of water. So water will compete with the electrolysis of the compound itself. So water will also undergo electrolysis to produce hydrogen gas and oxygen gas. So aside from the actual compound undergoing electrolysis, water will compete to produce hydrogen gas and oxygen gas, no? The electrolysis of water is the decomposition of water into oxygen gas and hydrogen gas due to the passage of an electric current. So water, diba, it's H2O, and we can only separate that into its elements, its components in their free form through electrolysis. So at the cathode, hydrogen ions combine with electrons from the external circuit to form hydrogen gas, and at the anode, hydroxide ions give up electrons to form oxygen gas. So I usually do this. So I use CHEM. So cathode, hydrogen is formed, anode, oxygen is formed. That's for the electrolysis of water. Because of this, there are two possible reactions. As again, because water will undergo also electrolysis, so there are two possible reactions that would take place at the anode and the cathode. So mura siya ma-combine ang electrolysis sa kadong molten nga electrolyte ug sa water. So at the cathode, pwede siya possible. So mura ni siya multiple choice. It's either A or B depending sa condition. It's either mo form og metal or hydrogen gas. Niya sa anode is either mo form og non-metal or oxygen gas. But the question is, how do we determine kung asa sa duha ang ma-produce? Kung metal ba or hydrogen gas ba? Or kung non-metal ba or oxygen gas ba ang ma-produce sa anode? So the substance produced in each electrode would depend on the half reaction that would require the least amount of voltage for the reaction to take place. Ang pinakagamay og requirement sa voltage for the reaction to take place, maoy mo happen diretso nga reaction. Okay, so here is the electrolysis of sodium fluoride. So for sodium fluoride, NaF, so it's an aqueous solution man, so it's either water ionizes into H plus and OH ions, diba? And sodium fluoride will dissolve in water to form sodium ion and fluoride ion. So there are two possible reactions at the electrodes. It's either in the cathode, the sodium metal is formed or the hydrogen gas, and at the anode, it's either the fluoride ion, the fluorine gas is formed, or the oxygen gas. So, asa ani nila ang ma-form? So, ang atong basihan would be ang iyang half reactions. So, these data, we get this from kadong standard reduction nga table. So, for water, diba, kadong mo form og hydrogen gas, iyang reduction potential is 0.828 volts. Ang pasabot sa negative meaning, kinahanglan siya, it needs, kay non-spontaneous man, it needs 0.828 volts for it to happen. And then for the reduction of sodium is 2.71. So asa may mas gamay kinahanglan? Kinahanglan siya 0.828 or 2.71. So of course, it's 0.828, no? So water, so mas gamay man ang need ni water para mo undergo siya og electrolysis, mas gamay man siya need nga voltage. So in this case, for aqueous sodium fluoride, water will undergo reduction, so it needs lesser voltage for the reaction to occur. And then, for the anode, so it's either ang katong water nga mo undergo oxidation produce og oxygen gas, so you still can find this in the reduction table, and it needs 1.229 volts. And then for the oxidation of fluorine to fluoride ion to produce fluorine gas, it needs 2.889. So obviously we can see that mas gamay og kinahanglan si water nga voltage para ma-undergo oxidation. So water will undergo oxidation, so it will need, since it needs lesser voltage for the reaction to occur. So ang reaction ang mahitabo ni nga electrolysis sa sodium fluoride is ang ma-produce kay kaning hydrogen gas o kaning oxygen gas, no? So the overall reaction therefore is the electrolysis lang of water. And ang ihang total nga voltage nga needed para mo undergo electrolysis is 2.06 volts. So interpretation, 2.06 volts is needed para water will separate into its component nga elements, hydrogen and oxygen. In this cell, water is converted to hydrogen gas and oxygen gas. What will happen to the sodium and the fluoride ion? They stay in the solution. Wala siya ni undergo og chemical change. So unsay nahitabo diri is gigamit lang si sodium fluoride to provide ions to carry the current to split water into hydrogen and oxygen. Gigamit lang si sodium fluoride para mo separate si water into hydrogen and oxygen.